In this video, we're going to look at one more technique for evaluating limits using algebra. We have this question, limit as x approaches -1 of x plus 1 over square root of x plus 5 minus 2. And the first thing you always do when you're trying to figure out a limit is just directly plug in what x is approaching. So we'll plug in -1 and see what happens. We'll plug in -1 here, and also on the bottom, -1 plus 5 minus 2. Simplify this a little bit. That's 0 on top. This square root, that's the square root of 4, so that's 2 minus 2 is also 0 on the bottom. So when we plug in -1 directly, we end up with 0 over 0, which is once again this indeterminate form that we talked about in a previous video. However, we can use our knowledge of difference of squares to change this function a little bit and get the limit much easier if we do that. Remember from algebra or algebra 2 that a plus b times a minus b is a squared minus b squared. It's the difference of squares. And we can take that a step further and say the square root of a plus b times the square root of a minus b is a minus b squared. And what happens is the square root goes away when it gets squared, and we're just left with a, which is what was inside the square root here. And we're going to be using this information to simplify this function so we can actually determine what the limit is. So what we're going to do is we're going to multiply by the difference of squares. We'll multiply by square root of x plus 5 plus 2. That is the conjugate to this, square root of x plus 5 minus 2 times square root of x plus 5 plus 2. And as you know, we can't just multiply by that. We also need to multiply this by this on the top as well. So we're actually multiplying by 1, square root of x plus 5 plus 2 over square root of x plus 5 plus 2. That's really just multiplying by 1. So we're not actually changing anything here. So we can rewrite our limit. And we'll multiply this through. On the top, I don't suggest you actually do multiply it through, because the goal of this is really to be canceling stuff out anyways. And if you multiply it through, it's just going to make that a little bit more challenging for us. However, on the bottom, we definitely want to multiply it through. Square root of x plus 5 times square root of x plus 5, that's just a regular x plus 5. And then minus 2 times positive 2 would give us minus 4. We'll clean this up just a little bit here. Let me rewrite it at the bottom. So we have the limit as x approaches -1, and I always rewrite this because we need to show that we're still evaluating a limit. X plus 1 times square root of x plus 5 plus 2, and this is just x plus 1 on the bottom as well. Now you probably recognize that x plus 1 is on the top and on the bottom, so here we can cancel out our x plus 1s, and we really just need to figure out the limit as x approaches -1 of this thing that's left. I'll write it one more time just to make sure there's no confusion here. Everything else got canceled out, so we're just left with this. Now we can use direct substitution and just plug in -1. And simplify, that's 2 plus 2, gives us a limit of 4. Let's look at one more example. The first thing you would do is plug in 3 and see if it works if you wanted to find this limit. However, if you plug in 3, you're just going to get 0 over 0, this indeterminate form. We can't determine what the limit is if we just plug in 3. So we need to manipulate this a little bit by using the method we just talked about. So let's multiply by the conjugate using our difference of squares. And in this case, the difference of squares is very similar. It's square root of 4x plus 4 plus 4 on the outside. It's really only this sign that ever gets changed when you're doing this type of manipulation. And we'll multiply by that on the top as well. Multiply it through. Keep writing limit. It says the limit as x approaches 3. If you forget to write this, it's not really clear that we're doing the limit anymore. Once again, I would recommend not multiplying through here, because the goal of this is just to cancel things, like we've been saying. So we'll keep this the same for now. And on the bottom, we will multiply it through, though. It's going to have the effect of canceling out the radical sign. Then we have -4 times +4 to get -16. Let's simplify that a little bit. Need to rewrite limit as x approaches 3, or it's not clear what we're doing. The top's going to remain completely the same. I can probably write it a little neater though. The bottom, however, is going to be 4x minus 12. And here's where we'd love to cancel something, but if you stop and look, you can't actually cancel anything here, right? Is x plus 3 up here, 4x minus 12 on the bottom. So at first glance, it might not look like you can actually cancel. However, you can rewrite 4x minus 12 as 4 times x minus 3. Just factoring out that 4. And when you factor out a 4, then you can cancel those x minus 3's. And you're left with this problem. The limit as x approaches 3, square root of 4x plus 4 over 4. And then you can try plugging in this 3 to find out what the limit is. So let's go ahead and plug in that 3. I'm going to go ahead and write it down here instead. So let's plug in 3. 4 times 3 plus 4 over 4. See if we can simplify this. That's 12, 16. Square root of 16 is 4 plus 4 over 4. And this tells us that the overall limit for this equation is 2.